First is permutations, next is combinations, but they are associated with each other. They are associated with each other. Okay. So we cannot learn the permutations in isolation. We cannot learn combinations in isolation. We have to learn them together. Okay. There are many concepts like which are basics for both the things. Okay. So usually when you take a situation, I'll take a situation where 3 persons are there. Okay. 3 persons are there. Among these three people, I have to select 2 persons. Basically, there is one competition going on, like table tennis competition, let's say. And I have been given a task to choose 2 people out of these 3 people to send 2 as a team. Okay. So in how many ways I can select 2 persons out of these 3 persons? You try. How many ways? 3 persons are there. You have to send 2 people for playing TT doubles. So in how many ways you can select them? 3 ways. Which all are those ways? AB is one. Then, so these are 3 ways of selecting 2 persons out of 3 persons, correct? Any other way? Okay. Now, I'll ask you to send 2 persons out of 3 persons, but by naming a captain and vice captain. Anyways, the second task is to send 2 people out of 3 people. But among those 2 people, you are naming one as captain, another as vice captain. So in how many ways you can send a captain and vice captain? How many ways? Who all are they? AB is also one. A is captain, B is vice captain. So this is captain, this is vice captain. Then interchange them. This is one more way. Then AC, interchange them. Then BC, interchange them. How many ways we can send a captain and vice captain? 6 ways. So difference is in front of you. The difference between permutations and combinations is in front of you. This is your combination. This is your combination. This is your permutation. Getting my point? So what is the difference between this and this? What is the difference between combination and permutation? What extra we have done here? Huh? Yeah. So basically here we have arranged. Here AB we have taken. AB. This is just selection of 2 people. So this is just selection of 2 people. Among those 2 people, if you want to name a captain and vice captain, how many ways we can do? A captain, B vice captain, B captain, A vice captain. So 2 ways, 2 persons are there, 2 ways we can do. So here in combination, it is only selection. It is just, like picking. It is only just picking. But in permutation, you pick and arrange. Getting my point? So obviously, for a given situation here is selecting 2 people out of 3. This is one situation. In this situation, always the permutations will be more than that of the combinations. For a given situation, that is selecting 2 people out of 3 people, like we will get more number of permutations than combinations. Is that clear? We'll get more number of combination more number of permutation than combination, because combination is just picking. After that, we arrange. So definitely permutations will be more than combination. This has to be kept in mind. Understood? This is a small example. I'll take one more. A, B, C, D. I have to select again two persons from here. I have to select two persons from here again for making table tennis team. Team of two. So in how many ways I can do the selection? Selection or combination? How many ways I can? How many ways? So there is one order of writing. Take A first for all the combinations. Then take B. Already AB is done. Take C. Only D is left. So these are 6 combinations that are possible. Like where we are selecting 2 out of 4. What about permutations? Again, we have to arrange them, no? So AB and BA. AB and BA. Similarly, AC and CA. AD and DA. BC and CB. BD and DB. CD and DC. So these are 12 permutations that are possible. Are you getting the point now? Are you getting the point? Yes? Yeah. So this is the visualization. When certain things are given or certain number of entities are given, certain number of persons are given, we are asking you to either select a few or select and arrange a few. When you are selecting a few, it is always combination. When you are selecting and arranging them, it is a permutation. Understood? Any difficulty to understand? It's okay, no? Lunch? Heavy? No. Okay, I'll see. Who all had light lunch? Okay, let's see. Understood this? No issues? Okay. Now going by theory. First we have to know. Yeah, now I know. People are getting scared. Sir is going to theory, but this is just to support our visualization. That's it. I'm not going to use them very often. N factorial. What do you mean by this? N factorial. I'm damn sure you have learned this one. Yes? What is factorial? Product of first n natural numbers. So if I start multiplying from 1, up to where I multiply? Or if you want to reverse, is it correct? Now, n factorial. Whenever we use n factorial, like do we get this one? So now tell me, what is 1 factorial? 1. Don't take 0, okay? Don't multiply up to 0. That is why I have taken only natural numbers. Then 2 factorial. 2 into 1. That is 3 factorial. 4 factorial. Again, don't multiply 4, 3, 2, 1. Already you have multiplied 3, 2, 1. 6 into 4. 5 factorial. 24 into 5. At least remember these 5 factorials, okay? These will help you in calculations. You don't have to work out every time when it has come in the problem, okay? Just remember them to add. So add to the list. We have a list, right? Squares, cubes, tables, percentages, so many things we have now. Yeah, add to that table. Yeah, done. Then what about 0 factorial? It is not 0, it is 0 factorial is 1. Done? No problem. Cool. Yeah, this is basic understanding of factorial, because we are going to use this factorial a lot of times in our calculation. Done? Can I erase this? Yes. Now, going by theory, like when we are calculating the permutations. So we represent this permutation by P. Whenever we are trying to calculate the permutations, P. Out of n items, we have to select R and arrange. This is the notation. When we say NPR, we are selecting and arranging R entities out of n entities. In the earlier problems, once I had taken ABC, so there are 3 entities out of which I am selecting 2. There are, in the next example, there were 4 entities out of which I selected 2. For this, the calculation is based upon n factorial. N here means in the first example 3, in the second example 4. And R is 2 in the first example and also in the second example. So when it comes to the denominator, it is n factorial divided by n minus R factorial. Fine. So I'll show you the evidence. N factorial is what? In the first calculation, here, how do you write it? 3 factorial divided by, so 3 factorial divided by 1 factorial. What is 3 factorial? 6 by 1. We got it? Yes. In the second case, 4 factorial divided by 4 minus 2 factorial. So that is equal to 4 factorial divided by 2 factorial. Don't cancel 2 and 4, okay? It is attached with factorial. You cannot cancel when factorial is there. Okay, 4 factorial value is how much? 2 factorial. So what is the answer? Fine. This is what we had to get. This is what we had to get. Yes. So note this down and take the examples also. Take the examples. Is it tough to imagine? See, you will ask me, sir, from where did it come? We are not trying to derive this formula in the class. I would require 10 times more classes if I want to derive everything in the class. Okay? So I'll prove this. Without using this formula also, how to calculate, I'll show you. That is my job. Okay? Here, I don't want you to remember this formula, but without formula also, how can you calculate that I will show. Okay. Now, you only focus upon the permutations. Combinations, don't worry. After a few minutes, I'll deal with the combinations also. Only focus on the permutations. In the first situation, where we had taken A, B, C, and we were arranging them. Correct? So there was one place for captain, another place for vice captain. One place for captain and another place for vice captain. Now just think, don't think of this formula, don't think of 3, don't think of 2 factorial, nothing. Captain's position has to be filled. Captain's position has to be filled. Who are eligible to become captains here? All. ABC, is there any restriction? No. So in how many ways I can make a captain? 3 persons are there. How do you make 6 captains? In how many ways you can make a captain? 3 pakka. So captain can be selected in 3 different ways. Done. Captain done. Now if the captain is done, how many persons are remaining now? 2. In how many ways you can make a vice captain? 2 ways. Or you will choose captain again to become vice captain. Is there a chance? Is there a chance? No. So captain can be chosen in 3 different ways and the vice captain can be chosen in. And your job is over. Your job is over when you choose both captain and vice captain. And is very important here. And when you choose both captain and vice captain, your job is done. So whenever and comes, you have to multiply. Your job is to what? Only to select a captain? No, right? You have to select a vice captain also. Your job will be done only when you select both. Getting my point? Only when you select both. Yes? So, how many ways? 3 into 2. How many ways we can select? 6 ways, right? Other situation. A, B, C, D were there. And among them, you had to choose a captain and vice captain again. How many ways you can choose a captain from 4 people? 4 different ways. How many ways you can choose a vice captain? Your job will be over only when you select both. 4 into 3 is equal to? Done. Simple. Am I depending upon this formula? Am I depending? No, right? Okay. So this formula will do what? In this case, 4 factorial divided by 4 minus 2 factorial. 4 factorial divided by 2 factorial. How do you write it? 4 into 3 into 2 into 1 divided by 2 into 1. I am not wasting my time to write this 2 into 1 and 2 into 1. Anyways, we are going to cancel them, right? I am directly writing 4 into 3 here. In this case, how do you write? 3 into 2 into 1 divided by 1. So simply why writing this 1, 1? So directly I am coming there. Got my point? Okay. Similar situation among A, B, C, D. You are choosing a captain, vice captain, and one standby. You are choosing a captain, vice captain, and a standby. Standby means if somebody gets hurt, then that person will replace him. Yeah. So you have to choose 3 people now. You have to choose 3 people now. First place can be filled in how many ways? Second place can be filled in how many ways? Third place can be filled in how many ways? What is this? Or apply the formula. Out of 4 people, you are selecting 3. What do you write? 4 factorial divided by 4 minus 3 factorial. So this is 4 factorial divided by 1 factorial. Same thing. Without using this formula also, we can easily calculate. Just imagine how many positions are there. First position can be filled in how many ways? Similarly, second, third, or whatever the number, then multiply them. Done. Similarly, this is vice captain, captain, vice captain. What about you have 5 persons with you, and you have 3 chairs. 5 persons and 3 chairs. In how many ways you can make people sit on these 3 chairs? In how many ways? First chair can be filled in how many ways? Second chair can be filled in how many ways? Third chair can be filled in how many ways? 5 into 4 into 3. Or indirectly we are calculating 5p3. 5p3 is written as 5 factorial divided by 5 minus 3 factorial. That is 2 factorial. So 5 factorial is 120, 2 factorial is 2. So this is 60. Done? Any issue? Okay, no? So with formula, without formula, you can calculate. But it is always easy to imagine the situation, write the product and calculate. No need to mention P, R and N. Done? Okay with this? Yeah? Oh. Next is combinations. And I told you, for a given situation, always the number of permutations will be more compared to combinations. Yes, do you agree? Number of permutations more compared to number of combinations. So when we are calculating these combinations, we write NCR. We write NCR. And I had told you that whenever we calculate permutations and combinations simultaneously for a case, always permutations will be more. That means we have to what? Take lesser than permutations. So first I'll take the permutations. And I'll divide by something so that I reduce the number. I divide by something, so that division is nothing but n factorial. So what it would become? NPR. How do you write it? Sorry, here not n factorial, r factorial. Again, I'll tell you not to use this formula. Okay? I'll show you how. So n factorial divided by n minus r factorial. This is for NPR. And so this r factorial, which is dividing the given number, that is making the number of what? The combinations less. Number of combinations less. So you can note this down. I'll give you examples what I had taken earlier. ABC I had taken, out of which we have to select 2. Out of which we have to select 2. So 3C2 we had to calculate, correct? 3C2 we had to calculate. So how do you write it? 3C2. 3 factorial divided by n minus r, that is 3 minus 2 factorial, then 2 factorial. So this is 6 divided by 1 factorial divided by 2 factorial, again 6. This is one more example what I had taken. 4C2. How do you write it? 4 factorial divided by 4 minus 2 factorial and again divide by 2 factorial. So 4 factorial is 24. 4 minus 2 factorial. 2 factorial into 2 factorial. So 24 divided by 2 into 2. Again, don't multiply 2 factorial and 2 factorial, okay? It will not become 4 factorial. Don't do any kind of simplification when there is a factorial mark. When you get rid of factorial mark, then only you can, what? Simplify. So this is what? 24 divided by 4. That is equal to 6. This is what we had got, no? In combinations. When we were selecting 2 people out of 4 people. AB, AC, AD, BC, BD and CD. This is what we had got. Yes, definitely they are less in number compared to permutations. How many less? Exactly they are half. Because here the R value is 2. When R value is 2, we will divide something by 2 factorial. That is nothing but dividing by 2. So we'll get half the number. Yes. But I'll show you some fun. I'll show you some fun. Here, we had to select 2 out of 3. There were 3 people. We had to select 2. What if I reject one person? Rather than selecting 2, can I reject 1? Out of ABC, I have to select 2. Rather than picking 2, can I reject 1? So in how many ways I can reject? Reject one person every time. 3 ways. A1s, B1s and C1s. So can you tell me this selection of 2 persons out of 3 fellows, selection of 2 persons out of 3 persons is as good as rejecting 1 person out of 3 persons? Yes or no? Similarly, if I am selecting 3 persons out of 5 persons, 3 persons out of 5 persons, isn't it equal to rejection of 2 persons out of 5 persons? Same, no? Can I write out of 7 persons, selecting 4 is as good as rejecting 3? I'll show you the proof. Here, how do you write 3C2? 3 factorial divided by 3 minus 1 factorial divided by 1 factorial. Here, correct? Yeah. Here, 3 factorial divided by 3 minus 1 factorial. So what does this mean? 3 factorial divided by 1 factorial into 2 factorial is equal to 3 factorial, 2 factorial, 1 factorial. Aren't they same? Aren't they same? Similarly here, 5C3, 5 factorial divided by 5 minus 3 factorial divided by 3 factorial. So 5 factorial divided by 5 minus 2 factorial and 2 factorial. So what do we write here? 5 factorial divided by 2 factorial, 3 factorial and 5 factorial divided by, both are same, right? Both are same, right? So you can interchange like this. Interchange depending upon the values of n and r. You can write like this, or I'll write a short form of this. When you are calculating NCR, it is as good as NC n minus r also. NC n minus r also. Again, don't get disturbed with this N, C, R, P and all. Just try to understand the concept. What is the concept here? Selecting 2 out of 3 is as good as rejecting 1 out of 3. Understood? Yep. No problem. After all these things, how I had told this one, rather than going for this big calculation, I'll directly write like this. So similarly, how to write for combinations? How to write for combinations? I'll show you. I'll take one example. Again, A, B, C, D, 4 persons are there. So here n is equal to 4 and C is equal to, I am selecting 2 persons. R is equal to 2. First, I'll show you how to calculate NPR without using formula. Then I'll show you how to write NCR. I have already told you, when n is equal to 4, we have to begin with 4. It is as good as selecting 2 persons out of 4 persons. But we are arranging. So first place can be selected in how many ways? First place can be filled in how many ways? Second place. So totally how much? Similarly here, NCR. You will go for that formula, no? 4 factorial divided by. So I'll show you a simple method. Here, what did we do? We had to start with 4 anyways. We started with 4 and started multiplying. Until when? Until 2 entities are done. First entity is 4, second entity is 3. Done. 4 into 3, 12. That's it. Okay, if here 5 was there and here 3 was there. For example, n is equal to 5 and r is equal to 3. Start with 5, end after 3 entities, not end after 3, end after 3 entities. Done. Coming to combinations, numerator will remain the same. Start with 4, end after 2 entities. Same thing. Because in NPR and NCR, the numerator will be the same. Only we'll get some denominator so that we can reduce. We started with 4, no? That was the highest n. Here, you start with 1. In the numerator, you started with the highest number. In the denominator, you start with 1. Again, start multiplying. Up to where? Up to 2 entities. That's it. The number of entities we are taking in the numerator should be equal to the number of entities we are taking in the denominator. 4 into 3 divided by 2 into 1. This is what? Suppose we were calculating NCR. Here NPR is 5 into 4 into 3. Let's say NCR. How do you do? Numerator, you have to write the same. 5 into 4 into 3. Denominator, start with 1. This is what? This is 5C3. But I have told you, 5C3 can be written as 5C3 can be written as 5C2 also. So while you are writing for 5C2, how do you write? You start with 5, end after 2 entities. In the denominator, start with 1, end after 2 entities. What is the difference between this and this? This and this? Nothing. Only thing, we are writing 3 extra in both numerator and denominator, which is simply waste of time. So, while you are writing NPR, start with n, end after 2 entities. That's it. End after r entities. That's it. Multiply. In NCR, numerator will remain the same. Start with n, end after 2 entities. In the denominator, start with 1 and end after r entities. There you will come across NPR and NCR. Here no formula involved. No formula involved. What you have to write in the numerator, I have told you, start with n, end after two entities, or end after r entities? R entities, not two, R entities. And in the denominator, start with 1 and end after R entities. Done? Feeling sleepy? I can see that this one. If you want some windows to be open so that that AC is on, come in front. See, afternoons, this fan is also, that's uniform speed, anything that is in uniform, that will make you sleep. You are comfortable, no problem. If you want that to be on, you can make it on. Fine, no? Yeah. See, sitting exactly below fan also, sometimes it will, this one, if you want to wash your face in between, go wash your face and come back. So understood, without involving any formula, how to write NPR and NCR. Done? Start with N and after R entities. In the denominator for combination, start with 1 and end after R entities. There ends the matter of permutations and combination. Okay? I'm not asking you to leave now. You have to solve the problems also. Only this much is there in this one. Only thing you need to visualize. But during our school days or college days, nobody has taken this much interest and gone deeper into the subject and made you visualize the things. And we'll start the class with NPR only. Okay, person will not understand what is N. To understand N and R, they will mug up for a week. What is N and what is R? You cannot define N and R. N are total given things. R is the things that you are choosing. That's it. Will you have to mug up? Just you have to visualize. That's it. Yes, P is what? Permutation. C is combination. Combination is always lesser than permutations in a given condition. And for given permutations, you have to divide by something. That division is nothing but division by n factorial. That's it. Sorry, r factorial. That's it. Understood? When you solve the problems, it will be pretty clear. We'll go to questions one by one. And here, I can create n number of questions, okay? Because these are up to human imagination. Okay, for example, these many people are there. Okay, these many benches are there. How many ways we can make sit? Okay, during COVID condition, okay, alternative seats have to be filled up. So in how many ways we can fill up the classroom? So all these are like different calculations. Okay, done? You can ask me, sir, how it is related to permutations and combination. See, always when we see the questions of permutations and combinations, the questions will be asked in this format. In how many ways we can dash and dash? In how many ways the things can be arranged? In how many ways the things can be selected? This how many ways, these are the options that we have. These are the options that we have. Okay, so we'll solve this problem. 8 railway stations, A, B, C, D, E, F, G, H are connected either by two-way passages or one-way passage. One-way passages, so let us write these down. Don't write randomly in such cases, because A, B, C, D, E, F, G, H, they are connected to each other in one or the other way. So have a proper space between them. So it is better to write in a circular manner, okay. So I'll start with A. A, B, C, D, E, F, G, and H. Okay. One-way passages. That means in that way, the vehicles can go only one way. It cannot come back. C to A is 1. C to A. E to G. B to F. Then D to H. G to C. E to C. Then H to G. Done. Then two-way patches. A to E. Then G to B. F and D. Then E and D. Correct? Yeah? No. Correct now? Yeah. Now, while traveling from C to H, which of the following station must be passed? C to H. So C is the starting station. We have only one outlet from C. So from C, we have to go to A for sure. Yes. Then from A, how many outlets are there? Outlets I am asking. That is towards. Then from E, how many outlets are there? One to A. Then one to C, one to G. So three outlets. So one is coming back to A. It is becoming a loop. Then from E, we have the way to C. And from E, we have way to G. Now check from C. See, anyways, when you come back to A, it will become a loop. Don't worry about that. So, C. C is here. How many outlets? So, rather than writing this C, what we can do? We can put a loop back to C. We can put a loop back to C. Then E to G. From G, again, where it is going? C. C to H we are going. For H, there is only one inlet. That is from D. Now, for D, there are two inlets from E and F. And from F also. But from F, there is only one outlet and one inlet. And it will come from B. Again, it will be complicated. What they are asking, while traveling from C to H, which one of the following station must be passed? From C to H. Anyways, A and D are compulsory? Or is there any way that you will skip A and D? A and D are must. G can be skipped sometimes. And here D is also compulsory. D is also compulsory. So A, E, D are compulsory. A, E, D are compulsory. So they are asking which one of the station must be passed through. Is there any chance that we skip A and D? Is there any chance that we skip A and D? A is compulsory, E is compulsory. Even D is also compulsory. Yes or no? Or is there any connect between G and H? No. H has only connection from D. So D is must here. So for this, again, A is must. From A to D, is there any connection? Direct connection, A to D? No, right? So A, E, D are compulsory. But here, we have two options, no? While traveling from C to H, which one of the following station must be passed through? Maybe the option problem. Maybe the option problem. You can make any one of them. Either I'll check the question once again. E and D, maybe you make this as B. Okay, then tick E. I'll check the question. This is a UPSC question. So this has come in the prelims. Next, in how many different ways can train from F to A without passing through any station more than once? That means no loop. Okay, F to A. F to A. F has only one outlet, that is towards D. And A has two inlets. A has two inlets, one from C and another from E. Now try to connect D and C or D and D. D and D, there is a connection. D and D, there is a connection. Then between D and C, is there any connection? No. D and C, there is no connection. Any other possibility? Any other possibility? How many different ways can train travel from F to A? This is one. F to D, then D to E, E to A. Any other chance? For C, from where it is coming? G. Can you connect G to D or F? Again, G will get connected by E only. So this is one way. This is one way. Correct? Another way, are there any other ways? F to A, F to D, correct? D to H, H to G, G to C, okay. F, then D, H, G, C, A. Any other way? Three ways so far? Three ways so far? Any other way? See, these are complicated. These are complicated because 8 stations are there. 8 stations. Okay. See if we are missing something. See, it doesn't have anything to do with NCR, NPR. But these are the ways of tracing. Ways of tracing from where to where it goes. I'll tell you the application when we come across some problems. Okay. So far 3. So far 3. First is what? F, D, E, A. Next is what? F, D, E, G, C, A. That's all. Anyways, F and D are compulsory. Here A, sometimes it will get connected with E and sometimes it will get connected with C. For C, like input is coming from G only and E. So here GC is compulsory. One more way, F, D, E, C, E. So these are 4 ways. These are 4 ways. Okay. We cannot apply any formula here. It is up to our imagination. It is up to our imagination. So it is not 3, it is 1. Okay. Or if you want to get the perfect answer for all the situations, you have to write from A to H, 8 stations, and you have to draw all possibilities with patience, then trace, but it is going to be difficult. Okay. Next question. If the route between G and C is closed, if the route between G and C is closed, so G has only outlet to B now. Okay. Which one of the following stations need not be passed through while traveling from H to C? We are traveling from H to C. One chance was there, HGC. HGC, but this route is gone now. Then H outlet is where? Is only to G. But for C, from where all the outlet is coming? E. Any other way? No. GC is cut now. So is there any chance between G and E? For E, the input is only from A. For A, the input is from C also. B also. For E, D, right? So GC route is cut, so this is not possible. So DEC or CED from backwards. So how to connect H and D now? How will you connect H and D? You have to connect H to D. How do you connect? H to G, G to B, B to F, F to D. So HG, BFD. H, G, B, F, D. Correct? Is there any other possibility? Okay. Then they are asking which station need not be passed? A. A need not be passed, right? All other stations we are crossing. 7 stations. Only one station we are leaving. Which one is that? A. Tough question, I know. So now we'll enter into the real world of permutations and combination. This is to show how many ways. I'll ask you a simple question. This particular problem is derived out of such situation only. There is city B, city A, city B, and city C. From city A to B, there are 3 ways. From city B to C, there are 2 ways. In how many ways we can move from A to C? In how many ways? I want to travel from A to C, okay? How many ways I can travel? Five or six? For a cinema hall, there are 3 entries and there are 2 exits. For a cinema hall, there are 3 entries and 2 exits. In how many ways you can enter and exit the cinema hall? How many ways? See, the main confusion is you are trying to add 3 plus 2. Actually, it is not. The first case, this is first route, second route, third route, fourth route, fifth route, and sixth route. So that is why we have to multiply. So permutations and combinations mainly like we have to multiply. So that is the thing. If I ask you a question, in how many ways you can get exit out of B, city B? In how many ways you can exit the city B? You want to get rid of city B. In how many ways you will get rid of that city? 2 ways. Which one? You want to get rid of city B. You can go to city A also. Single way? No, nothing like that. How many ways B can get out, or the persons from city B can exit? How 6? 1 way, 2 way, 3 way, 4th way, 5th way. Or you will come here and go. 5 ways. So that is where we are adding. So we can take these routes or these routes. So here comes or. Either these 3 or these 2. But here and. We have to go to B. Then we have to go to C. 3 ways here, 2 ways here, 3 into 2, 6. So these are basics. Direct questions won't come. This is for our understanding. Then we'll look into some problems. Now the fun begins, okay? Every problem is a fun. How many 3 digits number can be formed with digits 0, 1, 2, 3, 4, 5 if repetition of digits is allowed? How many places? As soon as you see the question, you have to write these 3 places. These 3 places you are going to fill, right? Yeah, hundreds place, tens place, and units place. Yes or no? Yeah. Now, you are going to form 3 digits out of how many numbers they have given? How many numbers they have given? 6. Now tell me, how many ways I can fill this place? First place can be filled in how many ways? 5 or 6? Why 5? So if we write 0 here, and give any number here, can you call that number as 3-digit number? That becomes 2-digit number. So you cannot fill with 0. So if you don't have the option of filling it with 0, how many options you have? 1, 2, 3, 4, 5, anything? Then this place can be filled in how many ways? 4 or 5 or 6. Okay, why 5? We can fill 0 also. Correct? We can fill 0 also. But why only 5? One already taken. But they are telling no. Repetition is allowed. So now tell me, 4 or 5 or 6? Last place, how many ways? Any of these 6 can be filled? Yes, done. Over. So now we'll add or multiply. How much is it? 180. Fine. Okay, in this question, if 0 was not there, instead of 0, I will give 6. What would have been the answer? 6 into 6 into 6? 6 cube. Yes? 6 into 6 into 6? The repetition of digits is allowed. Yes? Next question. How many 3-digit numbers can be formed out of these 6 numbers if repetition is not allowed? Think of these 3 places. First place can be filled in how many ways? 5 ways without 0. Second place can be filled in how many ways? Sure. Why 5? It doesn't mean that I have filled 5 here. One of the 5 numbers can be filled. This is 5 ways. So here how many ways now? You can take 0 also. So including 0 it can be 6. But already you have filled one number. You cannot take that number because repetition is not allowed. So how many ways? Last digit. Because already 2 digits have consumed. 2 digits have been consumed. So 5 into 5 into 4. How much it is? Fun? Am I using any formula? Fine? Okay, no. Are you able to digest? Yeah? Only thing you have to imagine correctly. First place should not be filled with 0. When repetition is allowed, you can have maximum number of choices. When repetition is not allowed, then you don't have maximum number of choices. Already the number what you have used, you have to forget them. Yes, done? Yeah, next question. How many 3-digit even numbers can be formed with the digits 0, 1, 2, 3, 4, 5 and if repetition of digits is allowed? What they are asking? Even numbers. So, for even numbers, what we have to do? Last digit should be either it is 0, 2 or 4. 0, 2 or 4. Yes or no? And repetition of digits is allowed? Yes. So in how many ways I can fill this place? Sure. How many ways I can fill this place? Anything can be filled here, no? The repetition is allowed. Why you are leaving these 3? These can be filled in 3 ways. These can be filled in any number, like the maximum number of ways. How many? What about this? 5 ways. Why? You are leaving 0. Very smart. 5 into 6 into 3. How many? Getting the hang of permutations and combinations? Yes? Only the imagination has to be proper. That's it. Here even number. So our condition should move towards the last digit first. Done. Tough. Any confusion? Ravi? No? Fine? Yeah? Now, repetition is not allowed. Repetition is not allowed. What to do? Here, when repetition was allowed, we had maximum number of choices. When repetition is not allowed, we cannot have that privilege. So our chances will be cut. So in such case, what you have to do? In such case, like think of this number first. I will put this as 0. When this is 0, this is number 0. Here, in the first place, how many ways I can fill? Have I utilized 0 here? How many numbers are remaining now? Any of those 5 can be filled here, right? So 0 is consumed here. One more number is consumed here. What about this? Because 2 numbers are consumed already. 5 into 4, don't multiply 0, okay? 0 is just a number we have taken. This is not number of ways. Number of ways cannot be 0. So 5 into 4 is equal to... Now I'll take the last number as 2. So how many ways I can fill the first number? Last number is 2. 4 or 5. I cannot fill 0, no? 0 can't be filled and 2 can't be filled. So 4 here. Here. Here one number is consumed. Here one number is consumed. 2 is already consumed here. Here one more number is consumed. And we can consider 0 also. When this is 4, how many ways I can fill this place? 4 ways. I cannot consider 0. Here, 2 numbers are already consumed. I can take. So 4 into 4. Here also 4 into 4. Totally. Correct. So when repetition is allowed, you have like full options. You don't have to go by category. But when repetition is not allowed, you have to think of each and every digit. You have to think of each and every digit. Okay, fine, no issues, sleepy, or will have a very light music, but that will induce sleep. Light music. Anything that is uniform, that means speed or the intensity of the sound. Anything that is uniform, that will induce sleep. Few people put fan in the night, not because of the heat. They want some uniform speed or uniform sound to be fed into the air. You can see people switch on the fan, but they will put, what is the use? Yes or no? They will take blanket, that to thick blanket they will. And the fan is running. The science is what? You want that sound because you are accustomed to that sound. When you have that uniform sound, gong, 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 then only will get sleep. Okay? So, sometimes that non-uniformity will avoid sleep. Non-uniformity. That means sitting in the same place, with the same posture, with the same book will induce sleep. Change anything, your position, place or the book. You will not get sleep. And I am finding people are not taking the support these days. They are told, no? Any support to this, our roof will induce sleep. Okay, to avoid. So one is the backbone erect position. Then avoid supporting your roof. Fine? Next. And one more way of avoiding sleep is having as less contact of the ground as possible. Reading while standing is more focused rather than sitting on the floor or using the gravity. Then few people have the attitude of what? Taking this position. Few people have this position, like Ranganatha Swami position. The next is what? And if after few seconds, book will fall on your face. There ends the matter. So these are the position, no? Reading while standing, then sitting, then. Yeah. And few people have, like this position. In this position, book will fall on them. In this position, they will fall on the book. Yes or no? And obviously in Ranganath Swami position, you have to support your head, no? Within few minutes. So best way to induce sleep is this. When you are not getting sleep out of anxiety, start reading like this. You will get sleep. Next, using 22333 as digits, how many distinct numbers greater than 30,000 can be formed? So 30,000 is having how many digits? How many? Yes, and we have to make the number more than 30,000. So first number has to be first number has to be 3, no? Is there any other chance? No. So now how many numbers are left now? How many numbers are left? 4 numbers. So how do you fill this? How many ways you can fill this place? 4 ways. Then how many ways you can fill this place? Tough, no? Tough or easy? How is it? If different digits were given, it would have been easy, right? If different digits were given, it would have been easier. Now same digits have been given. Tough. Yes or no? So we'll come back to this question after learning new concept. So that new concept is making the words out of letters. Making words out of letters. Simple way. When AB is given, don't think of meaning of the word, okay? Don't become, like the experts in English. Don't ask me. So that is why they give, while you are forming the words, they give with or without meaning. With or without meaning. So out of these two words, these two letters, sorry, how many words can be made? Out of A and B. Utilizing all of them. 2, one is AB, another one is, correct? S. Out of 3 letters A, B, C, how many words can be made? Put A, B, C. Keep A, interchange B and C. Now take B. Keep B and interchange. What I'm doing here by creating the number of words, arranging, that means we are making permutations, correct? Permutations of how many letters? 3 letters. Out of how many letters? 3 out of 3. If I take NPR, This is nothing but, that means what? Start with 3, end after 3 entities. Or simply it can be written as what? So when we take NPN, when we are taking all of them, it becomes what? N factorial divided by n minus n factorial. That is nothing but 0 factorial, nothing but 1. So NPN is n factorial. Yes. So now, when you are taking all the letters given here, that means when you are taking all 3 letters to make a word, so how many ways we can make 3 factorial or n factorial? Understood? Here 2 factorial. Now tell me, if you are taking A, B, C, D, all of them, if you are taking A, B, C, D, all of them, 4, how many words can be made? How many words can be made? Out of A, B, C, D, letters A, B, C, D, how many words can be made? With or without meaning? How many? 4 factorial, no? Yes? Now you can arrange. Like there are 4 places. First can be filled in 4 ways. Second can be filled in 3 ways. Third can be filled in 2 ways. And fourth can be filled in 1 way. So that is nothing but this. So while we are making words, look at the number of words. Look at the number of letters. Those many factorial. But there will be a problem if there are repetitions. For example, instead of ABC, if I give you AAB, instead of ABC, if I give you AAB, how many words you can make? One is this word AAB. Yes. Second one is ABA. Third one is, here this is happening because there is no distinction between this A and this A, correct? They are identical. That is why if this was A1, A2, then we would have interchanged A to A1 also. So in such cases also, what we have to do is look at the number of letters. How many letters are there? Put that in the numerator. In the denominator, check for repetitions. So what is repeating here? A is repeating. A is repeating for how many times? 3 factorial is 6. 2 factorial is 2. 6 divided by 2 is, correct? Yes? No issues? Done? Let us take few questions. How many different 5-letter words with or without meaning can be constructed using all the letters of the word Delhi, so that each word has to start with D? They are giving one condition now. The word has to start with D and it has to end with I. So first letter and third last letter is fixed. Now which all letters are left? E, L, H. This can be filled in how many ways? 3 ways, no? Then this can be filled in how many ways? This can be filled in D and I are fixed. And when they say using all the letters of Delhi, that means you have to use all 5 letters. 2 are already consumed. 3 can be put in 3 factorial ways. 3 into 2 into 1, 6. Any confusion? Understood? Yeah. Here we come across certain conditions. Condition can be anything. Condition can be anything. They will tell that L and H should be together. L and H should be together. They will tell L and H should not be together. Like that, many conditions can be put. Now, how many words with or without meaning can be made from the letters of the word mathematics? So mathematics, how many letters are there? Mat, he, mat, ICS. This is how we learned the spelling of maths for the first time. Because we were introduced to this very word only in 5th or 6th standard. We knew mathematics, but mathematics as a word in English, first time we heard it for the first time in 5th standard. Until then it was all Ganita, Ganita, Ganita. Tagani, Tagani, Tagani. Mat, he, mat, ICS. This was big event, To learn the spelling of mathematics was a big event for us. Mat, he, mat, ICS. So it was what? 11 letters. So 11 factorial for all the numbers. And how many repetitions are there? M is a repetition. How many times? A is a repetition. T is a repetition. Don't multiply 2 into 2 into 2. 11 factorial, keep it like that. What are the values of 2 factorial? 2 into 2 into 2. Then you can multiply and put it as 8. Don't put it as 8 factorial. 11 factorial divided by 8. Understood? This is simple. Take the number of letters in the numerator, put factorial, divide by, look at the number of repetitions. So according to the number of repetitions, you are putting the factorials. Okay, done? Now, small, this thing, a small exercise. Make the, the permutations of your own name. Quick. Don't use shortcuts, okay? Put your registered name and only your name, not initials and all. Quick. Done. Vinith, what is the answer? 6 factorial divided by 2 factorial. So answer should be 360. 24. So how many in the top and how many in the bottom? All 4. 4 factorial. Lalita? 7 by 2. Correct? 7 factorial by 2. Correct? No? Oh, L and A double. Okay. Saubhagya? No repetition. Only A is repetition. 14. Oh, you were. Oh my God. You can take one day. Okay. Yours, Malan? 8 factorial divided by 3 factorial. A's are 3. A's are 3. Anusha? 6 by 2. 11 factorial divided by 2 factorial into 2 factorial. 2 into 2. Correct? Oh, A once only, right? Okay. Vinith done. 5 factorial by 2. What's your name? Okay, TH. Okay. Okay. So 2 factorial and 2 factorial. 9 factorial divided by 2 factorial and 2 factorial. Quick. Okay. 11 factorial by 12. That is what? 3 factorial into 2 factorial. A's are 3. Then H are 2. 7 factorial by 2. What are the repetitions? A. Same. Okay. 4. Okay. H are 2, A are 2, T are also 2. Initial don't take. Okay. Anyways, you calculate later. By 2 factorial. Done. Okay, done. Ajay, you have taken Kumar also. Okay, fine. Done. Next. Manmohan. Look at the condition here. How many words with or without meaning can be made from the letters of the word Manmohan in which vowels are always together? Which all are vowels? A, O, A. A, O, A. These have to be together. When they give such condition, make a lot for them. Treat them as one single entity. A, O, A. Treat them as one single entity. A, O, A. Tushar Kapoor ke आवाज में. Yeah? You don't know the fun? No. Anyways, have you seen the Tushar Kapoor latest movie? Any? It is all Golmaal, right? Golmaal, regular customer. And he's what? Dumb. Dumb, no? He can't talk. That is why A, O, A. So all vowels are him only. A, O, E, O, I, O, U. No consonants. So that is the fun. And when we make fun, you are supposed to laugh also. But UPSC life, how made you, like so sober in life. You want to laugh, but you can't. Yeah, that fun factor is missing. Don't take it like that. When you are enjoying your life, then only you will clear UPSC, Enjoying the sense, small things. Only thing, you have to be fresh. You have to be energetic all the time. Whatever that makes you energetic and fresh, you have to do that. Not for 24 hours. At least for a few minutes, you have to do that. Yes? So, AOA has to be together. What all other letters? M, N, M, H, N. Totally how many letters? Without these, 5 letters. Wherever they go, they have to go together, these letters. Wherever they have to go, these 3 have to go together. Maybe they will come and sit here, but they will be together. Maybe they will come and sit at the last, they have to be together. Okay. Treat this as one unit. This is unit number 1, 2, 3, 4, 5. You treat this as one letter now. So totally how many letters are there now? Or how many units? 6 units. In these 6 units, how many repetitions are there? Don't think of AOA, okay? AOA is 1 unit. M for 2 times. Then N for. This is done for the entire word. Now you go and look into that small group. Which is that group? AOA. So how many letters are there? How many repetitions in AOA? Okay. Got it? So here 6 factorial is 720. Divide by 2 into 2. Into 3. Divide by 2. Sorry, into 6. Divide by 2. 2 into 2 into 2, 8. 8 ones are 8 90s are. 90 into 6, 540. So according to condition also you have to take. First, look at the condition and treat that as one single letter or one single unit. Look at the number of units. Look at the number of units. Then Look at the number of units, then look at the repetitions, then is that AC gas? AC gas? Huh? Done? So it depends upon conditions. The conditions can be anything. Conditions can be anything. Okay. It depends from problem to problem. But overall, whatever the condition that they give, you have to treat it as 1 unit. Then other things, you treat it as other units, totally number of units, and divide by repetitions, and go inside that this thing unit and look at the number of permutations. Done? Yeah. Looking at this AC gas filling, I remember one very, I can say very unfortunate incident. In 2015, we had gone to interview. Okay, we had gone to interview. Most of us were staying in Karnataka Bhavan only. I had not seen that person, but I had heard about that person. He was also giving interview. His name was Prashant, and he was from Kolar. He was staying in his friend's place in Old Rajendra Nagar, Delhi. Many of them asked him to come to Karnataka Bhavan so that we can have discussions and all. But he told, no, I'll feel disturbed there, so I'll be here only. So after 2 days, he had his interview, and this gas filling person had come. AC gas filling. Usually what happens, there is a limit in this AC, this thing. 1 liter, 1.5 liter, like that, there will be a limit. But out of greed, these persons will do what? They will try to compress more liquid into the compressor. So instead of 1 liter, maybe 1.2 liters, they will charge more, no? But compressor is very dangerous. Compression means what? You are compressing a gas. So if the compression has expanded beyond the volume, it blasted, and that person, he was just few meters away. Gone. He had interview after 2 days. So that is why, I didn't know when they had gone there. But when they were taking the cylinder outside, see, these small things, you don't know. That is why life is very fragile, very fragile. I suddenly remembered the incident 7 years back. This was the period when we go for the interview, summer. If he had stayed in Karnataka Bhavan, he wouldn't have died. Yeah, everything is destined. So don't worry. Enjoy today. Today is the ultimate thing. Enjoy means don't leave your work and go for only enjoyment. Whatever that you are doing today, enjoy that one. Enjoyment doesn't mean that you have to fulfill all your senses all the time. No. Whatever that you are doing, try to enjoy. Don't think that as a burden. Most of the aspirants, 80% of the aspirants take the preparation as burden, burden. You want to get rid of the preparation. You want to get rid of the exams. Longer the time you try to exit this, you will again put back to the same vicious cycle. So that is why enjoy the process. Never try to get rid of see, when you are writing the exams, the common feeling is what? Not to write the exams well. You want to get rid of the exams as early as possible. That is the general feeling. Come prelims day, you will say just 2 days before or a week before the prelims examination, I want to get rid of this examination. I don't know what will happen with the results, but I want to get rid of the examination. This is a negative emotion. Let that June 5th come. I'll enjoy those 2 hours, I'll get the maximum out of it. So that is the positive emotion. Negative emotion, I want to get rid of this examination. After this examination, I'm going to Himalaya. This is the feeling, but nothing will happen. Just before the examination, you will have all the dreams, Let this exam happen. See what I'll do. You will not do anything. You'll be in this tea shop only. You'll ask, like, you had big plans, no, sir? Summer. Nothing. And sir, I'm preparing for mains. So all those bahanas will come. So why I'm telling, you set the bigger plans, you will never execute. The bigger plans have to be broken down into smaller plans. Maybe the today's target. Have target for an hour. Finish off that. Take the next one. So like that. It's all mental makeup, like whatever that we do, it is all mental makeup. There is nothing physical. There is nothing like spiritual thing, nothing. So everything is here only. Metaphysical things, spiritual things, everything is there here. How do you plan? The way you execute. Yes or no? So this has to be very strong and calm, basically calm. You should not give reaction to anything. Maybe like very exciting thing. Okay. One day this excitement is going to die. One sober thing. Okay, this is going to rejuvenate one day. Don't become Sadguru or something, but become Sadguru for yourself. Don't depend upon other Sadguru for you. Become Sadguru for yourself. Okay. Next question. Permutation. How many words with or without meaning in which consonants and vowels remain in their positions? Consonants and vowels remain in their position means they have their own positions, no? How many letters? How many letters? 11. So here, what all are the places of consonants? Consonants means what? Except vowels. Yeah. Permutation. So these are the places of consonants. So how many consonants are there? 1, 2, 3, 4, 5, 6. So how many ways? 6 factorial. Repetition. How many repetitions? Permutation. Permutation. How many repetitions? 1 repetition of what? T. Then think of vowels. How many? 5. Repetition. A-E-I-O-U. E-U-A-I-O. All are Tushar Kapoor only. Like, there's no repetition. No repetition, right? So 5 factorial. Don't write anything in the denominator. 6 factorial into 5 factorial divided by 2. So this is 720 into 120 divided by 2. So what is the calculation? 43,200. What does this mean? These 6 consonants, they can interchange their positions. It is as good as 6 seats are there, 6 persons are there. They can interchange their position. So how many ways? 6 factorial. But when T and T interchange their position, there is no effect. When T and T interchange their position, there is no effect. So 2 factorial only. Then coming to consonant vowels. E, U, A, I, O. So this is what? These are vowels. Again, interchange the vowels positions. 5 seats and 5 persons. 5 factorial. So 6 factorial divided by 2 factorial into 5 factorial. So totally 43,200. Done? Yeah. Okay, we'll come back to this one. We had left one question here. Now, this position is fixed. How many places are left now? 4. What all choices we have? 2 2s and 2 3s. Correct? So how many letters totally? Repetitions? (24) by 2 into 2. That is 6. Done. So I'll tell you what all are those 6. Correct? 3322, 2233, 3232, 2323, 3223, 2332. 6 ways. Done. These are more confusing. If you try to work out this in the examination hall, you will not reach anywhere. Only 6 ways, but very confusing. I'll tell you, very confusing. So if we have this one, we have 4 options, but 2 are repetitions. 4 factorials divided by 2 factorial into 2 factorial. Done? Yeah. Very interesting problem. How many different sums can be formed with the denominations of rupees 50, 100, 200, 500 and 2000, taking at least 3 denominations at time? How many denominations we can take? How many? 3. Taking at least 3 denominations at a time. At least 3 they are telling. How many different sums can be formed with the denominations rupees 50, 100, 200. So 5 different notes. 5 different notes, and you have to take at least 3. At least 3. That means 3 or 4 or 5. At least 3 means what? 3 and more, right? So when we take 3, how many ways we can take? Notes here. 5 ways. Then how many different sums? So 5 ways. Then what it should be? 5 into 4 into 3. So 60 has to be the answer, right? Or am I misreading something? How many different sums can be formed with the denominations rupees 50, 100, 200, 500 and 2000, taking at least 3 denominations? Is it correct? Is it correct? So how many here? 5 into 4 into 3. Don't worry about the answer, we'll think later. Our method is correct, no? Out of 5 notes, how many ways you can pick a note? 5 times, 5 ways. Then second note, 4 ways. Third note, 3 ways. So 60 ways. So this is when we are taking 3 notes. When we are taking 4 notes, what will happen? How many? 120. When we take 5 notes, same now, 5 into 4 into 3 into 2 into 1. So actually, when 5 notes are there, taking 4 notes or 5 notes, it is the same thing. Because last one multiply by 1, it doesn't have any effect, no? So how much it is? Total? How many different sums can be formed with the denominations of rupees 50, 100 to taking at least 3 denominations at a time? About the answer, I'll tell. Okay. But I think this one is correct. Any dispute? Or I'm over reading something, under reading something? 4, 3. Okay, we'll check that one. Combinations will check. Why I'm taking the arrangement, how many different sums can be formed? Yeah, here, one thing. Here, order is not important. While we are picking 3 notes, order is not important. We are picking 3 notes, right? Are you arranging them? You are making what? Either you arrange like this or in this way, you are making the sum, no? So permutations we should not take, correct? It is about combinations. It is not permutations. We are not arranging them. We are making the sum out of that. Either you add A plus B plus C or C plus B plus A or B plus A plus C. It is all same, no? So it is about combinations now. So how many notes we are picking out of 5? And this is when we are picking 3 notes. How much it is? 5C3. How do you write 5C3? It can be 5C2 also, right? Rather than selecting 2 notes, you can reject 2 notes. So 5C2. Start with 5, write 2 entities. Start with 1 and write 2 entities. This is 10. Next, take 4 notes. That is nothing but 5C4. Nothing but 5C4. 5C4 is nothing but 5C1 also. Rather than selecting 4 notes, you can reject 1 note, right? So 5C1. That means what? Out of these 5, you are rejecting 1 every time. How many ways you can reject? That is nothing but 5 by 1, okay? Then 5C5. How many ways you can pick up all the notes? All the notes you are picking up only once. So there is nothing but 5C0 also. So always when it comes to 0 here, this is always 1. So 10 plus 5 plus 1, 16. Sorry, it is combination, it is not permutation. So first of all, you have to ascertain whether this is a problem of permutation or combination. Then you have to proceed further. We are making some, we are not arranging them. We are not putting them in the exhibition or in the gallery. We are just making the sum out of it. Yeah, no problem. There are 6 different colors available to choose from, and each of 3 wooden blocks is to be painted such that no 2 of them has the same color, in how many different ways can the winner stand be painted? Winner stand, you know? Yeah, winner stand. So there will be 3 blocks, 3 wooden blocks. How many paints are available with us? 6 paints. So first one can be painted in how many ways? Here arrangement is important, yes or no? When we are taking the color and painting different blocks, arrangement is equally important, right? Though I use RGB, red, green and blue, I can interchange them, right? To have a different look. Yes? So here this is the problem of permutations. Okay? So first block can be painted in how many ways? Second, and they are telling no 2 of them has the same color. That means everything has to be of different color. When they say no 2, that means not even 3, not even 4, not even 5. When they say no 2, it is 2 or more. That means what? Every block should be having a different color. So 6 ways, this one 5 ways, and this one 6 into 5 into how much? 120. It is as good as making 3% sit out of 6 on 3 chairs. This is nothing but 6p3. 6 into 5 into 4. Yes, done? Very good problem. If 2 boys and 2 girls are to be arranged in a row so that the girls are not next to each other, how many possible arrangements are there? Arrangements. Permutations? Yes. So how many girls are there? 2. How many boys are there? 2. What they are trying to say? If 2 boys and 2 girls are to be arranged in a row so that the girls are not next to each other, girls should not be next to each other. That means boys should act as walls between girls. Yes. Between 2 girls, there should be some boys. Yes or no? Is there any necessity that only one boy has to be there? Between 2 girls? Between 2 girls, is there necessity that only one boy has to be there? Even 2 boys can be there, no? In such cases, what you have to do is, here the condition is put on girls. Condition is put on girls. So better you fix up the positions of boys. Okay, because boys are acting as walls here. So I'll take B1 and B2, boy 1 and boy 2 here. Now, I have made boy 1 and boy 2 to occupy some places. Definitely, there will be a gap between them, or without gap also. That is possible. Now tell me, when I have fixed up the boy's position, how many positions are left for girls? 2. Which 2? This one and this one? What about this one? See, imagine, boy 1 is here, boy 2 here. Girl 1 can sit here, girl 2 can sit here. Or girl 1 can sit here and girl 2 can sit here. Similarly, tell me, girl 1 can sit here and girl 2 can sit here. And girl 1 here, girl 2 here, interchange, possible? So how many places do girls have now? 4 or 3? This one and this one, no? Correct? Yeah. So I showed you this and this they can sit and interchange. This and this they can sit and interchange. What if this and this are occupied? Girl 1 and girl 2 and interchange. Then you will ask me, sir, what about this place? Forget this place. Now boy 1 and boy 2 are like this. Girl 1 here, girl 2 here, and they will interchange their places. Yes. So simple here. In such cases, what you have to do is, the condition is put on girls. So fix up the boys' position. Fix up the boys' position. How many boys are there? 2. So boys' positions can be put 2 factorials. They can interchange their positions, no? Then, how many places are left for girls? 3. That imagination has to be proper. It is not just 2, it is about 3. So, girls can have how many ways? Like, this is boy 1, this is boy 2, and there are 3 places available, and 2 girls have to be 2 girls have to sit. Take the first girl. Take the first girl. How many ways she can sit? First girl. 3. Second girl. When first girl is sitting, 2 ways. So 3 into 2 only. That is 3 factorial. Simple. Boys have 2 positions. That is why 2 factorial. Girls have 3 positions. That is why 3 factorial. 2 factorial into 3 factorial. So this is 2 into 6. That is equal to 12. Done? We'll wind up here.